Hi, so today we want to be looking at the weight of a body in a lift. How does the weight of a body in a lift change? So the weight of the body in a lift actually changes, but the mass remains the same. I already said that earlier in the previous video that weight change can vary, but mass does not. So let's say that we have this guy in a lift, and the guy is standing in the lift. Now the guy has a weight which is a product of the mass and the acceleration due to gravity of the place. Then he has the reaction. The reaction is the feet of the guy, the legs of the guy on the ground of the lift. So that reaction, and as well. So we're going to be looking at about three cases. So the first case we're going to be looking at is when the lift is at rest. That means when it is stationary, it's not moving. So if the lift is not actually moving, then W, which is the weight, is equal to the reaction of the floor of the lift to the man in the lift, and that equals to mg, mass times acceleration due to gravity, when it is at rest. Now if it is not at rest, if the lift is not at rest, let's say the lift is moving upwards. Let's say the lift is moving upwards, like the lift is going up. So exactly. So what will the weight of the man be? Now remember that it's moving up with a particular acceleration. We don't know. Let's just say A. Let's just call it A. So now let's say the lift is moving up with an acceleration A upwards. Now the man is being pulled upwards by the lift. So remember that this guy is just standing stationary, but because the lift is moving up, it moves this man also upwards. Now what happens? So now there is an unbalanced force. That means the acceleration, the lift has to overcome gravity as it goes up. And remember that gravity, it has to overcome gravity. Now the unbalanced force is actually going to be given as R equals ma, that's the mass and the acceleration of the lift, then plus mg, the weight of the guy. Now, and that's going to be giving us, since both of them have m, I'm going to factor out m, a plus g. So now that means that when the guy is in the lift and the lift is going up, his weight is actually greater than when it is stationary. Let me give you an example. Remember that in the first case we said that when the lift is at rest, that W equals mg, right? So let's say the guy is 10 kg and the due to gravity is 10 meters per second squared. Okay, so the weight when it's at rest is actually 10 times 10, and that's about 100 newtons. This is when it is at rest. Now when the lift begins to move with an acceleration of, let's say, 5 meters per second squared upwards, now what's going to be the weight of the guy? That means the weight of the guy now has to be m into a plus g, and so that gives us 10 into 5 plus 10, and that gives us 10 times 15, and so that gives us 150 newtons when the lift is going upward. So what do you see? This is at rest, 100 newtons, upwards 150 newtons. So you see that as it moves up with a particular acceleration against gravity, the apparent weight of the man is increasing. Now, when the lift is moving downwards, let's say with A, what happens is that the reaction is actually given like this. The weight is actually given as mg rather minus A. So this is when the lift is moving downwards. So with example I'll be looking at, the mass is actually 10, acceleration due to gravity is 10, then the acceleration, let's say, is moving downward with the same acceleration, 5. What happens? That's 10 times 5, and that's 50 newtons. That's 50 newtons, and in this case is moving downwards. So that means you see that the man feels less heavier while the lift is coming down with a particular acceleration. Now, does this mean that if you get to a point that the man is going to feel weightless? Yes. So there's going to get to a point where the man is going to feel weightless, and that point is when acceleration, when the lift is actually falling under gravity, when A equals to G. So when it's A equals to G, when the lift is actually falling under gravity, so the person is going to feel weightless. W equals mg minus A. And what does that mean? That means that W becomes, mass is 10, acceleration due to gravity is 10 minus 10, and that's 10 minus 10 is times 0. So width is 0. So at this point, this is when lift is falling, we just call that free fall under gravity. So when anything is falling under gravity, the thing is actually weightless. So this is the concept of weightlessness. So that means if a man stays inside an aeroplane and the aeroplane is falling under gravity, everyone in the plane can actually feel weightless, and hence they can actually float like in the space. Yes, this is the idea behind weightlessness. So if anything is falling under gravity, let's say you're in a plane and the plane is falling under gravity, free fall, then everybody in the plane can actually float in the plane, just like in the space. So that's the concept of weightlessness. So watch out for the next video where we'll be talking about the application of Newton's third law of motion.